In part B of this equation, we're asked to actually solve the polynomial that we were given in part A. However, we know that x minus 3 is in fact a factor, and our aim here is to actually factorise this down into 3 brackets. So what we know then is x minus 3 is obviously a factor. That's obviously going to be multiplied by some quadratic now, ax squared plus bx plus c, and that will be the same as our polynomial. What we can do now is something called comparing coefficients. And if we look at our left hand side, the only way in which we can create an x cubed expression is by x times ax squared, which gives us ax cubed. So on the left hand side of this equation, the coefficient of x cubed can only be a. On the right hand side of the equation, the coefficient of x cubed is actually 1. So we now know that a is 1. The other thing we can obviously examine now are the x squared coefficients. So if we look at the left hand side, we have two ways of making an x squared expression here. Minus 3 times ax squared would give you minus 3ax squared. But don't forget x times bx, which gives you bx squared. So that's a plus b. On the right hand side, the coefficient of x squared is in fact minus 5. But when we looked at our x cubed, we worked out that a was actually 1. So we have minus 3 times 1 plus b has to equal minus 5. So minus 3 plus b is equal to minus 5. So b, add 3 to both sides, gives us a value of minus 2. The next thing I'm going to look at is actually the constants, i.e. the numbers on both sides of the equation. And the only way you can generate a number-only term on the left-hand side is multiplying minus 3 by c, which is minus 3c. On the right-hand side, we can see that the only term not in x is actually 24. So we know that minus 3c must equal 24. Hence, c must equal minus 8 divided by minus 3. What that gives us there is our coefficients of our quadratic on the left-hand side, which gives us x minus 3, x squared minus 2x minus 8. And that's equal to our x cubed minus 5x squared minus 2x plus 24. So now what we can do is actually factorise that quadratic, hopefully. And what we find now is x minus 3, and we have 2 brackets, and that should give us 2 brackets with minus 4 and plus 2 in. Once we factorise, it may take a little bit of time. And now we can actually replace that instead of our polynomial and make that equal to 0 as the question is asking us. This is very straightforward now. All we need to do is work out the values that would fit into all 3 brackets that would make each individual bracket equal to 0. Well, in this bracket here, obviously x would have to equal 3. In this bracket here, x would have to equal 4. And this bracket here, x would have to equal minus 2. Hence, these are the values that would actually work for solving that equation.